Hi guys, in this video we are going to discuss how to reverse a linked list provided a range. Okay, so we are provided with a range, let's say 3 to 6. So we have to reverse all the nodes in between 3 to 6 index. Okay, so what I mean to say, let's say we are having a linked list 8, 10, 11, 12, 13, 14 and 15. Okay, we are having this linked list and we are provided two values, let's say 2 and 4, 2 and 4. So what we have to do, we have to reverse the second to fourth node. We have to reverse all the nodes between 2 to 4. So this is first, second, third, fourth, fifth, sixth, seventh. These are indexing, and indexing is starting from 1. Okay, this is given in question. So basically what you have to do, we have to reverse 2 to 4 nodes. So from here to here. So what will be our new linked list? 8, 12, 11, 10, 13, 14 and 15. This will be our new linked list. This should be our answer. We have to return 8. We have to return the starting point of our new linked list. Understood? So this is what we have to do. And before explaining the solution, I will request you to watch the previous video in which I have explained how to reverse a linked list in K group. Okay, so basically we are given a linked list and we are given a value K, and we have to reverse the linked list at K intervals. Let's say K is 3. So we have to reverse for 3 nodes. After that, we have to reverse 3 nodes, then 3, then 3. Understood? So that video will be very helpful. If you watch that video, my explanation will be of 5 minutes. Understood? Because if you will not watch that, I have to explain that also. So our video will be very lengthy. Understood? So just watch that video. After that, you will not come to this video. You will solve this question automatically. Understood? So let's say we have to reverse from 2 to 4. Okay, so what we will do, we have to traverse the whole linked list. We will start traversing. We will initialize our index value with 1. Okay, so initially it is 1, current is 8. Okay, then our current will increase. We will come to this node and we will check whether this node is in between range or not. Yeah, so our smaller value is equals to 2. So we have to start our actions from this point. Okay, what we will do simple, very easy. We will create two nodes, temporary tail, which is initially null, temporary head, which is also null. Understood? We will create two nodes, and what we will do, basically what these nodes are representing, these nodes will represent a linked list, a starting point and ending point of a linked list. Understood? So what I will do, I will segregate this from 2 to 4, from 2 to 4 nodes. I will segregate these nodes. So basically 10, 11, 12. I will pick them out. And I will get this 10, 11 and 12. I will pick them out. Understood? And I will remove these nodes from the original linked list. Okay. So because of this new linked list which I am going to create, I have to put some pointers at the starting point and ending point of a linked list. Okay, so temporary tail and temporary head, these are the two nodes which are representing the starting and ending point. Okay, so I got 2. So I have to start our actions from this point. Firstly, I will save its next pointer. So I have saved 11 because I am going to do some actions. I will explain you why. So I have saved 11 in some nodes. Let's say temp. So temp includes 11. Okay. Now what I will do, I will pick up 10. So 10 is picked up, and the next pointer of 10 will be null. I will make the next pointer of 10 will be null. Okay. So 10 is alone. 10 is not pointing anything. Now what I will do, I will start add first function. I will pass this value to add first function. What add first does, let's say we are having 3, 4 and 5. We are having 3 nodes. Okay, and I provide you a node 6 which you have to add first in this linked list. So basically what our function will do, our function will put this 6 in front of these nodes. Okay, our function will put 6 in front of these nodes and we will get this linked list. We will get this linked list. Okay, so why I am doing this? Why I am passing 10 to my add first function? Because I have to reverse this linked list. I have to reverse this linked list, and whenever I will get some element, I will put it in front of something. In front of something. So I got 10. So I will put 10 in front of temporary head in front of temporary head. So initially it is null. So our 10 will remain 10. Okay. Now I got 11. I will check whether 11 is in between the range. Yes, 3 is in between the range. So I will pick 11. I will pick 11 and I will put 11 in front of 10. That is, I will put 11 in add first function. So what 11 will do? 11 will come in front of 10. 11 will come in front of 10. Okay. Similarly, I got 12. So I will check whether 12 is in between range to 2 to 4. Yeah, 4 is equals to 4. So I will pick up 12 and I will pass 12 to my add first function. So what it will do? It will do this. It will do this. So what I got 12, 11 and 10. I got 12, 11 and 10. Easy. So our temporary head is present here and temporary tail is present here. Okay, I got this. You understand how we got this temporary head, temporary tail and this linked list? We got this. Okay. Now what I have to do? I have to do simply I have to point this 12. I have to point this 12 just after the just previous index of our starting range. So our range is starting from 2. Okay, so if somehow I can attach this 12 to the next of first index node, what I mean to say, at first 8 is present. Okay, so 8 is present. 8 is just exactly like it was earlier. So I got 8 and I will attach the next pointer of 8 with 12. So this will do 12, 11 and 10. Why I picked up 8? Because 8, the index value of 8 is just previous than the starting range. Okay, to create the whole linked list, I am performing these actions to create the whole linked list. Now I got this, and in a temporary head is present here, temporary tail is present here, and our main head which was provided in the question is present here. Okay, after that what I will do, I will simply put the temporary tail next pointer and attach it with the just after element of our ending range. So our range is ending at 4, and I will attach 10 with range 5 element, range 5 index 5 element. So 13 will be attached here and 13 is attached with 14 and 15. Okay, so this will be my new linked list, and you can see from 2 to 4 the elements are reversed. Our elements are reversed now. 8, 12, 11, 10, 13, 14, 15. 8, 12, 11, 10, 13, 14, 15. So I got our answer. We got our answer. So this is what I am going to do. Exactly this is what I am going to do. So let's start the code. Firstly, I need temporary head, which is null, list node temporary tail. Okay, so this is exactly same is which we have done in our previous video. Okay, now the same work which we have done in previous video. Now what I have to do, add first node. What it will take a node, and what I have to do, I have to check whether temporary head is null. Initially it was null. So when temporary head is not pointing anything and I am providing a node which should get fit into these two values, so what it will do, it will simply point to that node, and temporary tail will also point this to this node. What I mean to say, let's say I am providing you a node. Okay, so I provided you a node, and let's say I given you a value 5. Okay, so what will be the value of temporary head and temporary tail in this case? So temporary head will also point this, and temporary tail will also point this. Understood? Now we are having one node only, so both the pointers will point to the same node. This is what we are doing. Else, if this is not true, then what we have to do? We have to put that node in front of our temporary head. Let's move again. We are having 5, and I provided you one more node, 6. I provided you one more node, 6. So what you will do? I asked you to put this node in front of 5. So our answer should be this. So what you will do? You will connect the next of this node with temporary head. So this is, and you will shift temporary head to this point. Understood? When I will ask you to add 5 in front of 6, what you will do? You will add the next of 6 to 5 and just shift the temporary head value. So this is what I'm going to do. Node.next should be equals to temporary head, and temporary head should be equals to node. Basically, this line is shifting our temporary head value. Okay. Now let's write the code. Now what we have to do? I have to check some basic conditions. If head is null, then what we cannot do any actions. Okay. If head.next is null, that means we are having only single node. This is also false. If n equals to m, okay, what this situation is saying, then I have to simply return head. Now, if n equals to m, that means I provided you two numbers, 2 and 2. So what is the range? The range is 0. You have to reverse 0 elements, so this will not affect na. Let's say 2 in this list, so 1 and 2. Okay, so you will start from 2 and you will end at 2, and you have to reverse 12, so you will not get any value. So this will remain exactly same as provided. Okay, so that's why I have seen the condition n equals to m, then simply return. Okay, after that what I have to do? I have to create a pointer which will which will traverse the linked list. Okay, so initially it was present at head. I have to create index value which will start from 1. Simple. And now what I'm going to do? I will create previous node which will basically I will tell you. Let me write its name, list node just previous node, then n. What this name is suggesting, just previous node then n. So we are provided an n, and this node will be just pointed before the lower range. Okay, so initially it is null, no problem. Now I will start my loop. Current is not equals to null. You have to perform some actions. What are the actions? Okay, so here I'm going to write if index is greater than equals to n and index is lesser than equals to m. Okay, so basically I am checking two conditions, whether our index value is in between n and m. If this is true, so what I will do? I will create a while loop. Which will traverse all the nodes in between the range. So while index is greater than equals to n and index is less than equals to m. So in this while loop is what this while is doing. This while loop is picking up all the nodes in between the range, and then what I have to do? I have to firstly save the next node. Okay, so save the next node. So current.next. Okay, I saved it. Then what I have to do? I have to put null to its next. What I am doing? Let's say I picked 13. Okay, generally I picked 13. So firstly I will save its next node. So 14 is saved. Save is here. Okay, then I will put the next pointer of 13 as null, so that I got only 13, and then I will perform some actions, which is add first node and just pass the current pointer. After that, just shift current to save. Understood? After that, what I have to do? I have to increase the index value. This is must. Otherwise, this while loop will go into infinite loop. Okay. So our work of while loop is completed. Okay. Okay. This is the case. This is the case when I got. This is the case when I got the index in between the range. Okay. So what if this index value is greater than range? What will be the case if let me erase this, 8, 10, 11, 12, 13, 14, 15. Okay, range is 3 to 6. So 1, 2, 3, 4, 5, 6 and 7. So this is our range. This is our range. Okay. Now when index value will be greater than m, when index value is greater than m, then what it is suggesting? It is suggesting that I have reversed my linked list from range, in between the range, and then the rest of the part will exactly attached with the temporary tail. Understood? So when I will reverse this, I got 14, 13, 12 and 11. I got this. Temporary head is present here, temporary tail is present here. Okay, if index value is greater than m, that means I reached 15. So what I have to do, I have to attach temporary tail with 15. I have to attach temporary tail with 15. This is what I am going to do. This is exactly what I am going to do. I will write if index value is greater than m. If index value is greater than m. So what I have to do, I have to attach temporary tail dot next should be equals to current. Current is reached 15. When current will reach 15, so I have to attach this. Okay. And one more thing, I handled the back part. What I have to do, I have to attach the previous part also. I have to attach this part also. Understood? So for this part, we will do some tricky work. I am lefting it. Lefting for previous part. Okay. Now, if this is also not true, this is also false, this is also false, that means we are in the initial phase of our linked list. Initial phase, that means in this range is 3 to 6. So when we will reach 1, what are the actions we have to do? When we will reach 1, what are the actions? We are not required to do anything. Okay, now we are not required to do anything. We have to simply current equals to current dot next, and we will shift our previous pointer. We have created a pointer. Okay, so I will explain you what this pointer is doing. Current. Okay, what this pointer is doing, initially it is null. Okay, I am expressing it with JP. Okay, so initially it is null, current is here. Okay, after that current will move to its next and JP will move to this point. Okay, after that let me remove this to make it cleaner. I am doing this. Understood? So let's do it again. Initially current is here and JP is null. Okay, when current will move here, JP should be here. JP represents the previous node, just previous node. Okay, when current will move to this point, our JP will move to this point. Okay, this is previous point. Now we have to stop, because we got our point, we got our previous point. What we will do, when current will reach here, what it will provide us? We are within the range. What it will provide? It will provide me 14, 13, 12 and 11. We are provided with this linked list. Okay, so my previous point is here and my temporary head is here, temporary tail is here. So what I have to do, I have to just attach previous to temporary head. Okay, this is what I'm going to do. After moving out of the index value, what I have to do, I have to attach this pointer to temporary head, and then just simply return the original head value. What we have to do, we have attached that means 8, 10, and 10 is attached with 14. So 14, 13, 12, 11 and 11 is attached with 15. So 15. Now we have to simply, or let's say there are more elements, then also we have to simply return. We have to simply, after attaching 15, we have to simply return. That's why I am returning. But I have to check one more condition here. I have to check one more condition, which is, let's say in this case only, if the value of range, is starting from 1 to 3, so 1 to 3 means current is here, and we have to start our segregation from this point only. And at this point, previous value is null. And what I have written here, just previous node dot next. That means null dot next. It will give us exception. So I have to check if this value is null, then I have to do some work. Then the basically then the head value will simply reach at 12. I will not take this. I will write here is not equals to. And then I will simply copy this code. X and paste it. Understood what I am doing? I will check whether this is not equals to null. If this is not equals to null, then simply attach it. After that, just simply return head. Understood? Now I think we have written the code. Let's run this code and check whether this code is working or not. And after that, after all of these operations, we have to simply return head. So let's run this code. Okay, we are getting wrong answer. I don't know why we are getting wrong answer, but we are getting wrong answer. Okay, let's see. Okay. We forgot to increase the index value. Forgot the index value, because we have to increase the index when okay, this cursor, when current is here, index is 1. When current is here, index is 2. So we have to increase the index value. Okay, so we have increased it. After that, we are running our code, and now our code is accepted. So I hope you guys understood what we are doing. There are three parts in this video. First part is the initial phase. Okay, again, let me see what is the problem which we are doing. If index is greater than m, if index is greater than, or we can simply write equals to m plus 1. This will not affect our answer. No, okay. If we are doing everything correct, but some test cases are failed, so I'm figuring out where we are doing mistake. Okay, so let me run the code, submit again, and we will check what are the errors. Let me check the error. Wait for the compilation. So let's see what is this is input, and this is actual output is this, and expected output is this. Okay, so basically it is not appending our answer. The initial part is missing, the expected. So we can see that 15, 19, so initial part is missing. So we are doing some mistake in this part. Okay, let's figure out what we are doing. If this node is not equals to null, that means there is something present. Then we have to simply put it, this is correct. And if this is not true, then we have to put head at temporary head. Okay, I was missing this condition. I will explain you what is the missing condition. I will explain. Okay, now our answer is correct. Now let me explain what we are doing. Okay, so when my linked list, when my range is starting from 1, that means 1, 2, 3. Okay, 1, 2, 3. Okay, this is my range. So at this point, our current, what I will get? I will get 11, 10, and 8. I got this. Okay, I have attached the back part successfully. But now my head was initially at 8. my head was initially at 8. Okay, and now also my head is at initially at 8, but I have to return 11. I have to return 11 because previous is null. I am explaining the case where previous is null. Understood? So when previous is null, our main pointer from which the linked list will be starting is th. This is th. Okay, now we are getting this. This is th and this is tt. Okay, so we have to put our head at th position. This is what we are doing. This is what we are missing. So we have seen all the cases. We have seen almost all the cases in this question. Understood? So I hope you guys understood what we are doing, how we are doing, and you know what is the criteria, how we are following the initial part of our range, in between the range, and just after part of our range. Okay, so we have settled down, and now I will ask you to do this question, do some dry run, and perform it on your own. Understood? So we will meet in the next video. Until then, bye.